Assalamualaikum warahmatullahi wabarakatuh and good day to all. I am Muhammad Zakor bin Yaakob. My student ID is 2023520371. Currently, I am studying in Master of Science in Mechanical Engineering, CEEM 750. Today, I will be presenting my progress report with the research title of Dielectric Materials for Electrowetting on Dielectric Mechanism. During my research, I was supervised by Dr. Elinadia binti Abdul Latif. For introduction, since the last decade, electrowetting on dielectrode (EWOD), which is derived from the phenomena of electrowetting, has been widely researched and worldwide acknowledged as a promising technique for liquid manipulation and actuation. The EWOD technology has been widely used for a variety of applications, including lab-on-a-chip, optical devices, thermal management, solar concentration, and surface research, due to the benefits of enormous pressures at micro-mesoscales, a quick reaction time in the millisecond range, and straightforward implementation. In addition, most of EWOD research aims to design the mechanism that will be reduce device power consumption, employ new dielectric materials of device, and optimize device size. However, various components with very inherent material qualities have distinct effects on the performance of an EWOD device. Digital microfluidics (DMF) is commonly implemented in two different ways, which are closed and open format. For the closed format, also known as two-plate format, as we see in left side of the picture, in which the droplets are placed between two electrode plated substrates, the substrate contain driving and ground electrodes respectively, and the open format, which is we can see in the right side of the picture, also known as the single plate format, in which the droplets are arranged on top of a single substrate, which houses both actuation and ground electrodes. In both arrangement, an insulating layer of a dielectric material is put on top of the actuation electrodes to restrict current and avoid electrolysis. Generally, an extra hydrophobic coating is applied to the insulating layer to limit droplet adhesion to the surface. For problem statement, there are two problem statements that we used to solve in this project. First thing first is expensive materials and high cost fabrication process that typically used in EWOD method. And second is the occurrence of surface contamination in biomolecular assay such as protein that can make difficult for the electrowetting to process. There are three objectives for this study. First is we need to characterize the surface morphology of the dielectric materials. Next, we need to evaluate the electrowetting response of the dielectric materials. And last but not least, we must determine the dielectric properties, which are dielectric constant and breakdown voltage, to ensure that our materials can be used in electrowetting on dielectric mechanism. There are four scopes of study for this research, which we can see on the slide. First, we need to understanding the fundamental principles and mechanisms of electrowetting on dielectric surface. This involves the manipulation of liquid droplets using electric fields and dielectric materials to control the wetting behavior on solid surface. Next, we need to exploring different dielectric materials, which is PU material, and their properties that are suitable for the EWOD mechanism. Furthermore, we need to analyzing the wetting behavior of liquids on dielectric surface under the influence of electric fields. Last but not least, we need to studying surface modification techniques for dielectric materials to control and optimize their wetting properties. These may include surface roughness, chemical functionalization, and nanostructuring. For literature review, we focus on do some research on previous studies that's similar to our research project title. Okay, firstly, Chang et al. Describe the characteristics of an EWAT device using aluminum oxide created by atomic layer deposition (ALD) for the first time as a high K dielectric for significantly reducing the EWAT driving voltage. The measured threshold voltage to move the droplet was as low as 3 volt, the lowest voltage reported so far in EWAT research. Next, Kumar et al. Focused on the possibility of using SU8 as a hydrophobic layer in conjunction with functioning as a dielectric in a device. It has been demonstrated that an SU8 microchannel in the current design permits microfluidic flow at tens of voltage, similar to more expensive and difficult to produce design reported in the literature. In addition, Abdelgawad et al. Show an innovative, simple and low-cost microfabrication method for digital microfluidics. In this article, devices are created from copper substrates or gold compact discs using rapid marker masking to replace photolithography approach. Besides that, saran TM wrap, polyethylene film and commercial water repellents were applied to replace frequently used and more costly materials such as Perylene C and Teflon AF for dielectric and hydrophobic coatings. Last but not least, a novel ion gel material was presented by Narasimhan et al. As a spin-coatable and high-capacitance dielectric was used in this research for low-cost EWAT applications. They studied the principles of an ion gel dielectric, its spin coating production technique, and its interaction with a hydrophobic layer in actual EWAT applications. For now, this slide shows the research methodology of this project. So you can see it for 30 seconds and then we go to the next slide. So in this slide we display the table for contact angle measurement of hydrophobic materials, which consists of liquid-proof and Renapur. And this table also show the data collection and data analysis for the thickness of the dielectric layer, which consists of polyurethane and acrylic that we use as a dielectric materials with a different curing process and deposition method. In this slide, the figure shows the table of the average roughness of the dielectric layer for both the dielectric materials that we use in this project, which is polyurethane and acrylic, with the different deposition, which are spin, dip, and spray coating. The slide shows the figure of Gantt chart that mention our activities for completing my research. So as we can see, there are many activities that we can do to complete the research, such as project title registration, conduct literature review, and all the research methodology that have been mentioned before. So for now, the project title registration, planning and scheduling, conduct literature review on electrowetting on the electric EWAT, preparing of the shelf materials, and coating all the off-the-shelf materials by using the deposition methods have been complete in this semester, and we hope that we can complete the others activities for the future. So in this slide shows the status of publication that we achieved during this semester. We also display the status of my thesis writing, and it is better from previous semester. So for next semester, we target to publish the journal paper publication and to collect data and analysis the data that we didn't start yet in this semester. So hopefully we can do it proper and target to achieve the result in on time. So this is the list of reference that I used earlier for literature review section. That's all from me. Thank you.